So this is for the law of sines. We're going to do another question. This question involves an ambiguous case that does not have a solution. This is question number 4 from the guided notes in 6.1, the law of sines. The triangle is triangle CDE. The measure of angle C is equal to 85 degrees, and C is 15, E is 25. Step 1 will be to go through and find angle E. Let's draw our triangle. I start with the fact that angle C is 85 degrees. Remember, directly across from C is side C, and side C is 15. Go ahead and place angle D and angle E. I have the fact that across from angle E, I know that is 25 degrees. That's why I'm going to go ahead and start by finding angle E. Now, to set up that ratio, what I have here is I have 15 over the sine of 85 is equal to 25 over the sine of angle E. If I solve for the sine of angle E, I do that just by cross multiplying, and I'm going to divide by 15. So I get the sine of E is equal to 25 times the sine of 85 all over 15. All right, so let's look what happens here. This is why I have no solution. This is saying that the sine of angle E is equal to 1.660. Well, that's not possible because the domain, meaning the value of the sine, has to be between -1 and 1. Think back to the graph of our sine. The graph of our sine went from 1 to -1 over a period of 2 pi. That's it. So there is no solution for this particular question. All right, so let's go ahead and move on, and we're going to do another question from the guided notes. This time we're going to do question 5. So question 5 has angle F equal to 18 degrees. So I'm going to go ahead and draw this triangle in. Angle F is a small angle. That's only 18 degrees here. That's kind of a key that we are probably going to have 2 solutions with this triangle. Remember, directly across from angle F, I have side F, which is equal to, in this case, it is equal to 8. And let's label that angle F. We're going to call up here G and H. And directly across from G, I have the fact that G is equal to 12. So first thing I'm going to go ahead and do is, because I know that G is 12, I need to find angle G. So going through and setting this up, I have the sine of G over 12 is equal to the sine of 18 degrees over 8. So the sine of G is equal to 12 times the sine of 18 degrees all over 8. So if I plug all of that in my calculator, I get the sine of G is equal to 0.46325. Now to find out what that angle is, I go ahead and do sine -1. Now in my calculator, what I do here, so I don't have to type all of this in, I go ahead and hit second answer in my calculator. Or you can go through and plug the decimal in, but if you do that, at least make sure you have the absolute minimum of 4 decimal places. And I do that, and I get that angle G is equal to 27.6 degrees. Now, this is where we have to be careful because of the fact that this is an ambiguous case of the piece. I could have driven my triangle like I have up front, in which case I have a smaller angle, which is 27.6. So let's fix that triangle that I have, make that a little bit smaller of an angle. Because really what this means is that angle F is going to be really small at 18 degrees. Then I'm going to come in here and angle G is 27.6 degrees. And I need to find out what H is. I do that by going through, and that tells me that this angle H here is 134.4 degrees. So I have all of my angles of the triangle. I know that this side is 12, this side over here is 8, and the last side I need to go ahead and find is H. I go through, I can find H by doing H over the sine of 134 is equal to 8 over the sine of 18, and I'll go ahead and get H is 19 here. But the problem is I have a second choice for G. Because this angle G could have been a larger angle, it could have either been like this as a small acute angle, or it could have been a larger triangle that goes the whole way. I have to go through and solve this for the second triangle. So I'm going to move this up a little bit. And now I'm going to go through and solve for the second possible triangle. So when I said that G was 27.6 degrees, what is the other possible G? I get that by doing 180 minus my 27.6, which gives me that angle G could also be 152.4 degrees. This absolutely is possible. So we're going to go through and draw that second triangle in with the same beginning angle for F. So this time, what I have for that angle, again, F is still 18 degrees. But now, angle G is 152.4 degrees, which leaves me angle, so that leaves me with angle H as a 9.6 degrees. And that's why I have a second possible triangle. So going in from the beginning, what else did we start off with? We started off that G was 12, and we also started off that F was 8. So to finish solving this triangle, we just need to find out what h is. And do that the same way that I did before. So to go ahead and find out what h is, I have to set this up. I have that h over the sine of 9.6 degrees is equal to 8 over the sine of 18 degrees, which gives me the fact that h is equal to 4.317. If I round to the nearest whole number, I get h is equal to 4. So those are the two different possibilities that you can have for the ambiguous case of the sine. You can have one triangle, no triangles, or two triangles.